Hello all and welcome to exercise 5i, where we're going to look at the quadratic formula. Okay. Now don't get too concerned, it might look a little bit scary right now, but we'll move through it nice and slow and have a look at what it is and how we use it. And you'll soon realize that it's actually incredibly powerful and not that complex. And when I was in high school, before I became a teacher and realized the importance of all the different forms, is I always just reverted straight to the quadratic formula. Okay, didn't matter how simple the problem was, even if it was one that you could do via inspection. It was just I had trained myself to use the quadratic formula all the time because I knew it worked all the time. Or we'll get to about what I mean by working all the time. But it didn't matter if your answer was going to have surds or if it was pain or if you had to complete the square, you could always use the quadratic formula. But before we get into that, I'll talk about how we should use it, how we should have it. So if we have some quadratic, okay, the different ways that we have is that if we have a is equal to 1, we want to use inspection. And then if inspection doesn't work, we're going to use complete the square. Okay. Now if a doesn't equal 1, so if our coefficient at the start, remember we're talking about something, oh, that's terrible. We're talking about something that looks like ax to the squared plus b of x plus c is equal to 0. Okay. If a, this coefficient here, isn't 1, we would use the cross method. Okay. But the cross method, okay, is just a fancy form of inspection and it relies on the numbers being pretty nice. Okay. But what if the numbers aren't pretty nice? Well, this is where we get the quadratic formula. Now also, we can add on here the quadratic formula. Now technically, if the quadratic formula is going to work here, completing the square should work as well. Okay, but you can use the quadratic formula over on this side if a is equal to 1. Okay, but it's mainly for when a is not equal to 1 we want to use it. So what is the quadratic formula? Well, it is this thing right here. Okay, and it tells us the answers, okay, to any quadratic, tells us the x values, it solves, I guess we should say. It always finds the solution, provided there is one, okay, of this quadratic ax squared plus bx plus c. And how do you use it? Well, you take your a value, you take your b value, you take your c value, and you put them in here. Okay? And you'll be surprised, but you'll actually memorize this formula. You'll use it so much going forward, especially year 10, but definitely year 11, year 12. You'll use this so much you'll remember this equation. It's negative b plus or minus the square root of b squared minus 4ac all divided by 2a. You will remember that come the end of this. So if we were looking to solve this quadratic here, well, our a value is 2, our b value is 3, our c value is negative 5, and you'll put it in this equation. Okay, and you'll put in this equation, you'll solve the equation, and that'll tell you what your x values are at the end. Now, I'm going to clarify something here, okay? Providing there is a solution. This works providing there is a solution. What does this mean? Well, quadratics, okay? Quadratics look like this, okay? It's a curved graph, okay? The solutions we're finding, okay, this whole equals 0, that's our values when y is going to be 0. That's going to be our intercepts, okay? Now, that's one type of quadratic, okay? Generally looks like that. We have two more. There is one that comes down, okay, and just touches, okay? So this first one, there is two solutions, okay? You'll get two values of x, okay? This one is only, because it only touches once, it's not touching the x-axis twice, there is only one solution. Okay? And then we have a third type where it's curving like this, okay, and the graph never crosses the x-axis, so there are no solutions. Okay, so this quadratic equation always works providing there is a solution. So that means it's working for this one here where there's either two solutions or this one here where there's one solution. If there is no solutions, you'll run into an issue where you're trying to take this square root. This b squared minus 4ac is a negative number. And that will come to a negative. You try and take the square root of a negative number. It doesn't work. That means there are no solutions. So let's have a look at that. Okay, this bit in here has a special name. Okay, it is called the discriminant, and we use a regular triangle. That's its symbol for the discriminant. So here, this bit here, b squared minus 4ac, is called the discriminant. Okay, it tells us, as I was talking about over here, it tells us if we're going to end up with two solutions, one solution, or no solutions. Okay, so our discriminant is equal to b squared minus 4ac. It doesn't include the square root sign. We don't include the square root sign. Okay. Now, if the discriminant, if this whole thing, okay, if our triangle, okay, discriminant is less than 0, it means we're eventually going to take the square root of something that's less than 0 or a negative. It doesn't work. That means there is no solutions. If the discriminant perfectly, so that was that one. If the discriminant perfectly equals 0, we can do that. The square root of 0 is equal to 0. Okay, that means there's only going to be one solution. Now, if the discriminant is greater than 0, which is generally most of the questions you're going to be given, there is going to be two solutions. Okay, and when, okay, and this following bit down here, okay, when the discriminant, okay, is greater than 0, okay, and it's a perfect square, so if we solve this b squared minus 4ac and we get 1, 4, 9, 16, 25, 36, blah, 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 on and on, when we take the square root of it, we get a nice whole integer number. That means our final answer for x is going to be rational. That means there's going to be no surds in it. Okay? Now, if the discriminant is not one of these perfect squares, it could be 22, 53, any sort of number that is not a perfect square, and by perfect square I mean 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, that's what these numbers here are. Okay. It's not that, then our solution will be irrational, that is, it will involve surds. So let's have a look at using this. So quick review, the discriminant is this bit in here underneath the square root sign, b squared minus 4ac. If we solve that and we get less than 0, there's no solutions. That's this bottom graph over here. Okay. If we solve the discriminant and it's equal to 0, that means there's going to be one solution, which is this graph here where it just touches. And then if we get greater than 0, if the discriminant is greater than 0, that means there's going to be two solutions. The graph looks like that. Okay, so let's have a go. So quickly, let's write we'll use the discriminant. So first off, we're just using the discriminant. We're not actually finding the solutions. Read the question, determine the number of solutions. Okay, so just find out how many there are. And if there are two solutions, state the nature of them. Okay, are they rational or irrational? So the discriminant, okay, is equal to b squared minus 4ac. Remember that, that's our discriminant. So in this case, we're going to write down our values. So and our general form is ax squared plus bx c. Okay, so that's our a, that's our b, that's our c. So a is equal to 3, b is equal to -4, c is equal to -1. So our discriminant is equal to, and this first one I'm going to show the full working out so no one gets lost. Okay, b squared -4 squared minus 4 times by a is 3 times by c is 1. So -4 squared is 16 minus 4 times 3 is 12, and that's -12 times by the -1 is +12. So we get +12. 16 plus 12 will, 28. Okay, so we got 28. So therefore we can say there is two solutions, okay, because our discriminant was greater than 0. Okay, and 28, that's not a perfect square. It's not 4 squared, it's not 3 squared, it's none of them. So we will have irrational solutions. Okay, so that means we'll have surds. Let's do B. Okay, so we have A is equal to 2, B is equal to 5, C is equal to -3. Okay, just taking this value, this value, this value. We put it into our equation, b squared minus 4ac. Okay, so b squared, get 5 squared minus 4 by a is 2, c is 3. And we've got to be really careful with our signs because it is important. And -4 times 2 is -8 times by -3. So -8 times -3 is positive 24. So we get 25 plus 24 equals 49. Okay. Therefore, we have two solutions again. Okay. Because our discriminant is greater than 0, positive, and it's 49, which is the same as 7 squared. So we have rational solutions. We will not end up with any surds. We won't end up with any surds, which is really nice. Now we'll do C. Okay, so A is equal to 4, B is equal to 3, C is equal to 7. Okay, now a big hint that you're probably maybe looking at not having any solutions is when C is a big number. When C is a big number and it is positive, it is likely, just the way the b squared minus 4ac, because our c is over here, we might end up with a negative solution because we're going to have 4 times c. So if c is big, this gets big. Traction, it's going to nullify the square. We might end up with a negative discriminant, so no solution. So let's have a look. So discriminant is equal to 3 squared minus 4 by 4 by 7 is equal to 9 minus 4 fours is 16, and 16 times 7, or 7 sixes are 42, 7 ones are 7, plus 4 is 11, is 112. So 9 minus 112 will be negative. Take 9 off that will be 103. Okay. Therefore, we have no solutions. Okay, because our discriminant is less than 0. It's negative, so we have no solutions. And since there's no solutions, we don't have to worry about them being irrational or rational because they don't exist. So that was using the discriminant. Now let's use, that was only this little bit in here, in the red box. Let's use the full equation. Okay, find the exact solutions. Okay, so we have A is equal to 2, B is equal to -2, and C is equal to -1. Now a good habit is to just do the discriminant first. Okay, just do the discriminant first. Okay, so equal to b squared minus 4ac. That's going to be 4 minus 4 by 2, take 1. It's going to give us 8. 4 plus 8 is 12. Okay, so our full equation, x is equal to, okay, negative b plus or minus the square root of b squared minus 4ac, our discriminant bit inside, all on 2a. We can actually write this now as negative b plus or minus. That's right, yep, plus or minus the square root of the discriminant on 2a. Okay. And by doing the discriminant first, you know if there's going to be solutions or not, because there's no point doing this whole big full quadratic equation and then getting to the point where you get a negative square root and you go, oh, there's no solutions. It's much smarter to do your discriminant first, and then if you get to this stage and you're getting, if you get to this stage here and you're getting something less than 0, you can just go, no solutions, and you're done. You don't have to worry about anything else. But we did get a positive number, so we are going to have solutions. So we get x equals, now negative b is 2. So b is negative 2. Take the negative of that. That gives me 2 plus or minus the square root of 12. All on a is 2, so 2 times 2. So x is equal to 2 plus or minus now the square root of 12. Same as the square root of 4 times 3. That's 2 root 3. 2 root 3 all on, and I'm going to go 2 by 2 because I can cancel 2 off. So we get a solution of 1 plus or minus 1, 2. Okay. Because it wasn't a perfect square, we've ended up with a irrational number, square root 3. I can write this just to show you it is 2 solutions. Plus 1, 2, or it's 1 minus root 3, 1. 2 solutions, which what our discriminant said we should get. Plus or minus. Let's do B. A is equal to negative 5, B is equal to 9, C is equal to negative 3. So we'll start with our discriminant because we want to make sure we're actually going to have solutions. C equal to 9 squared minus 4 by negative by 3. That's going to give 81 minus 20 by 3 minus 60. That's going to give us 21. So we have 2, therefore 2 solutions. So x is equal to negative b plus or minus the square root of the discriminant all on 2a. So b is 9, so we're going to get negative 9 plus or minus the square root of 21. On a is 5, so we're going to get 2 times negative 5. That's going to give us negative 10. So that is equal to, now 21, that's 7 times 3. That's about it. So we can't simplify that third. So that's as simple as the answer can get. So we can write that, either leave it as that, or we can write it as negative 9 plus root 21 on negative 10, or we can negative 9 minus root 21 10. That's our 2 solutions. Now you could cancel off the negative signs on this second one, okay, because that's the same as writing negative I 1 plus 1 10. Negative. Yeah, so you can write it that way. Extension question. We'll leave this. Okay, but that's it. That's using your discriminant and then using the quadratic formula. Okay, this will work for all quadratics as long as there is a solution. You can use your discriminant first to find out if there is going to be solutions, and if there's not going to be solutions, well then you can just stop. And that's why the quadratic formula is very powerful, because it saves you some time. Okay, extension question. For what 2 values of k does the equation negative 3x squared minus 2kx plus 3 equals 0 have one solution? Okay. So what's going on here is we have an a equals 3, a b is equal to negative 2k, and c is equal to, that's in our quadratic, ax squared plus bx plus c equals 0. Okay. And you're probably already thinking this is a big problem most of you are coming across is you're like, oh, it's different. Different, it has a letter in it. It has a letter in it. Doesn't change. Okay, do what you would do before. Okay. For something to have one solution, what must happen? Well, for something to have one solution, the discriminant needs to be equal to 0. So that means b squared minus 4ac needs to be equal to 0. So let's do that. Let's do this. So b squared in this case is 2 all squared minus 4 by a, which is 3, by c, which is 3, equals 0. So we square this out, we get 4k squared minus 12 by 3, 36 equals 0. Okay. Now, what do you do from here? Okay, we need to find, and it's even telling us what two values of k. Okay. So some of you may have noticed, some of you might not have. That's completely fine. What is this? What have we now got? Okay, what do we have? Right here, we have a new quadratic. Okay. It's completely separate to this original one we started with. It's related to it. It's talking about the discriminant, but we have this new quadratic. Okay, and we can solve this. Okay, it is 4k squared minus 36. Okay, that is the same as 2k squared minus 6 squared equals 0. That's a difference of perfect squares. So we can get 2k minus 6, 2k plus 6 equals 0. So we can then use the null factor law and say that 2k minus 6 is equal to 0, or 2k plus 6 is equal to 0. So we get k is equal to, take the 6 over and then divide by 2, that's going to be 3, or k is equal to negative 3. Okay. We could do that. The other way we could do it though, and we did it in exercise 5 ABCD in 5H. Okay, this is also sort of turning point form. Okay? Here and here looks very much like that. We can just solve it algebraically. So we have 4k squared minus 36 equals 0. We can say that's 4k squared equals 36. Okay. K squared equals 36 divided by 4 is 9. So k is equal to plus or minus the square root of 9. K is equal to plus or minus 3. Look at that. It's exactly the same. So what does all this mean? Well, we got this k is equal to 3 or k is minus 3. Let's look back to our original. Okay, question. For what two values of k does the equation 3x squared minus 2kx plus 3 equals 0 have one solution? One solution. Well, if we put in, we just found k is equal to 3 or k is equal to negative 3. If we put that into here, okay, that'll give us a quadratic that just has one solution. That means graphically, it means the quadratic is just going to touch the x-axis. Okay, that's what we found. Now, this is a pretty advanced thing. You'll cover a lot more of it in Year 11 methods, but it was just a little intro to it in using the pair of the quadratic. That is it for exercise 5A, and that is it for chapter 5. So, a quick review. What was all of this about? Well, we started with quadratics. Quick review, we started with quadratics, which look like ax squared plus bx plus c. Okay. And we could factorize them a couple different ways, and that depended on if a is equal to 1 or a does not equal 1. If a equals 1, we would try inspection first. And if that didn't work, we would try complete the square. Now, if a didn't equal 1, we would try the cross method. And now we've just added a new thing. If the cross method doesn't work, we can use the quadratic formula. Now, the quadratic formula will also work for over this side as well. But complete the square should work. If quadratic formula is going to work, complete the square should work. But sometimes you can jump straight to this. Now, what's the power of the quadratic formula that the other methods don't have is that it has the discriminant well today, which doesn't look like I can, discriminant, which tells us the amount of solutions. Tells amount solutions. Okay. So pretty much to sum up, we looked at quadratics. We factorized them using a bunch of different methods, and once we factorized them, it allowed us to use the null factor law or the quadratic formula to find the solutions, and the solutions are just telling us the intercepts. Thank you very much. If you have any questions, like always, stick them on the Edmodo page or in the YouTube comments below. Bye.